looking at the first two questions that have been done so far, you assume so many things. But this was, I think it's Form 2. You did something like this in Form 2, right? Yeah. There was a time I think I covered a class in Form 2, and they were having similar area and volume of similar shapes. So I remember this particular topic in Form 2. Yanko, do you mind suspecting that? Some of you got it right on that day, but now I'm seeing a lot of misconception on your paper, so which is why I want us to look at this. So this is for area, this is for the volume. Now what I want you to do is this: at the back of your notes, on the piece of paper, random worksheet, something irrelevant, it doesn't matter, find the area of A, shape A, find the area of shape B. Now I want you to tell me, what is this ratio? This is length of A, ratio length of B. Okay, just put it as fraction. Okay? Then area of A, ratio area of B. See what you notice. Okay? Then come here, length of A, ratio length of B. Then volume of A, ratio volume of B. Tell me what you notice. Then that will inform what you want to do. I need to see what you have written. Don't just raise your hand and tell me what answer is. Write down on the paper, sir.
Length of B.
Length of B, yes.
Length of A.
Okay. Write down on the paper, please. Tell me what you notice about these four ratios. Find the four ratios and observe something, some kind of connection. So the idea is, how if two shapes are similar, what is the connection between their areas? If two shapes are similar, what is the connection between their volumes? That's the idea. Oops, we did that. You made it disappear. Now this is what you guys have done. We're going to see if this is right or not. Now this is what you have done. We're going to see if this is right or not. Then also for the volume in question 2, you have assumed this ratio. We're going to see if this is right or not. So, the four ratios, who has done it? Okay, 1, 2 people out of 25. 3, 4. I'm waiting for the others. 5. Raise your hands once you finish the four ratios. Don't worry about the additional one that I wrote. You just, mind your business. Which is the four ratios? Not my business. My business is written in that one. This is your business. The blue business. Are you done? Okay, great. The four ratios, and try to think of a connection you can see in the ratios. Alright? You see a connection already? Raise your hand if you are done. I need more than half of the class to finish these four ratios before we proceed. We don't have half yet. Now everybody's
What?
This is why I ask you to just limit your answers to 1 and 2. Have you seen something? Okay, Trudy, let's start with you. What do you notice here? Trudy. You know what I mean by LALB? Not like Los Angeles. Okay. Length of A, length of B. Length of one side. Just pick any length of A. They are similar shapes, so one is an enlargement of the other, so it doesn't matter which one you pick. Remember, if two shapes are similar, the ratio of their lengths are the same. So that's why 3/4 is equal to 6/8. Okay, so give me length of A. 4. Length of B. Yeah, just pick anyone. And this is going to be 1 over 2, right? And if you pick this, you get the same 1 over 2. So easy. I think you're complicating the whole thing, complicating it in your head. You don't have to. Now, what is the area of A? 12 cm squared. Well, we don't need to put cm squared. We don't know if it's cm. It could be kilometers. Okay, it could be the American way, miles. You know, they're kind of weird. Well, pounds. Wait, what is the unit of pounds?
LBs.
How is that pounds?
Labus.
I don't understand Americans.
Yeah, when you said pounds, I should go with the pounds.
No, not money.
Like,
Oh my God, you
because I
like
don't
money?
Think of that. Labus.
You know, even the pounds that is money is this. So we understand this, the Great Britain pound. There's a P there. But the Americans, LBS.
Labus. There's an S there.
Yes. I want to buy 5 lbs of sugar. Come on.
5 pounds of sugar.
That's a lot of sugar.
I'm just saying, like,
You get diabetes.
You get it.
I'm not talking about what happens. I'm saying, that does that sound? Anyway, we never understand the Americans, so it's fine. Now, area of B. What is area of B?
48.
Okay. So let's get the ratio. So what's the ratio now? 12 over 48, which is what? 1 over 4. Is there a connection? Are these equal?
Square.
No.
No. So how can we make them equal? This is not correct, right?
No.
So how can we maintain the equality? What do we need to do?
Square.
Square what?
The
You speak
length.
louder, miss.
Square the length.
You square the left-hand side, the length one.
Oh.
Okay? What about this one? Has anybody, you cube the left-hand side. So whenever you have a question on similarity, you start with this. You start with this ratio.
Again? Today I was 3.
It's 3.
Oh, come on, what are you guys doing to me this morning?
Just remind me.
So this is how I want similar shaped problems solved. Everybody look up. Because now, the reason you are having this misconception is because you are not, you just want to use mental math. And that's what I'm trying to show you this morning. You just want to use mental math. Oh, I'm going to divide by 2 and I'm going to times 2 by something. That is all you want to remember. Excuse me, I'm talking to the whole class. The reason, again, you are writing, because this is how most of you did number 1. You did 14 divided by 7 is equal to 2. 2 times 20 is equal to 40. This is what I saw all through, the ones I checked. And that's because you just want to have it in mind, oh, is either I divide or multiply or whatever. You just want to perform operations on numbers. Always start from the relationship. I'm not just forcing you to show steps. Once you are used to this routine, you will never forget, even in 5 years' time. Does it make sense? Always start from the relationship. So if I have 2 shapes that are said to be similar, for example, this is 2, this is x, and I was told the area of this is maybe 50. And now I'm looking for the area of that one. Okay, let's see. I need to start with the length of the first one divided by the length of the second one. It doesn't matter which one is the first, which one is the second. Maybe I write this as 4, perhaps. Hope that works. Change it to 100. Let's see. Okay, now, then area of the first divided by area of the second, something like this. How about I use that example. This is 48. This is 6. This is x. Okay? This is maybe 28. This will be 12, right? So now x is missing. There are 3 variables involved here. The 2 length and the 2 area. Only one should be missing at the point. So all I would do is start from the relationship. If you were used to starting from the relationship, nobody will write this. And trust me, more than 90% of the solution I saw was exactly like this. Then it's not working. Don't just memorize, I'm going to times, I'm going to divide. There's a reason for it. Okay? So, if you have your relationship established, substitute. Okay? If you substitute, what is LA? Not like Los Angeles again. That's X. LB is what? Area of A,
Well,
area of B.
for A.
Then everybody can do this. Okay? What's the first thing to do?
Square.
Square.
Square roots. You don't need square. Let's find the square root of the other side. If you want to do square, it's fine. But this is what happens when you do square. You have x squared over 36. You have, this is going to be 1 over 4 eventually.
Yeah.
So it's got to 1 over 4. Then you have 4x squared equals 36. Then you are going to do x squared is equal to 9. You're going to do square root. But if I find the square root straight away, x over 6 is square root of 1 over 4.
Oh.
I get smaller numbers. Do you understand? So I perform the roots first to minimize, the complication of numbers. Is that clear? You will do it, of course, with calculator. This will be easier. Imagine if this is 75 and maybe this is 120, maybe this is another complex number. You get what I mean? So it's always good to just use this approach. So if x over 6 is 1 over 2, isn't it easy to do? 2x is equal to 6, then simply x is equal to 3, which is what we use here. Does it make sense? In both cases, you will get 3, of course. Of course, if I write x is square root of 9, am I allowed to write plus or minus 3? Remember, square root of 9 is plus or minus 3, right?
But you can have negative.
I cannot have negative 3. Why?
Because it's a length.
It's a length of side. You don't say length of side is negative. What does that even mean?
There's no length.
Okay?
No, there's less length.
Do you understand? Alright. So please, this is the beginning I want to see. For every question you are solving in that worksheet, begin with this relationship or that relationship. I want to see the relationship written for every question. I want to see the substitution and how you proceed. Is that clear? Thank you. We'll take a picture and post this on the video, and of course you can see it in the video later as well. Of course. But work it neatly, please. You can write in your notebook, so you do not forget, but it's not mandatory. Sometimes you can find the square root directly, sometimes you need to reduce before you find the square root. For example, 12 over 48 is not a perfect square. Can you see that? So I had to reduce the fraction first. It's possible you can find it directly. Okay? So, yeah, you won't be able to find square root until you expand. If the unknown is the area, then you need to deal with the square first. So in that case, that's allowed. You can't find square root. Does everybody understand what I mean?
Yes.
If your substitution is something like this, maybe, yeah. Guys, if the substitution is like this, oh, is that when we find square root? Yes. Yeah. 3 over 6. Yeah. Class, please. Attention, please. If you have this substitution, remember what I said about doing the square root first. You can't find square root here because the unknown is here. The reason we are finding square root is we want to get rid of the square, right? To isolate x. X is already isolated on one side without any power. So you can't do the same. You have to evaluate this first. Reduce it, find the square. Okay?
Square it first.
No, I think it's, if you square it first, you get 49 and 196. That's too big. So why don't you reduce it first? You should start from here next time.
So
When you
write
get
the
to
equation.
you can write like this. If you write this one here, then I see it already. I just need to make it compulsory for everybody to use. Right? When you erase it, start from here. That's the same thing I was telling him. There is still.
This is why I have multiple erasers.
Because of the eraser stealing people. I'm trying to reduce your font. We don't need a microscope to see this. Next time we will use, I just wanted to
No, this one's the
Because when you square that, you get 4. 1/4. And that's the calculation. But you don't have a calculator.
So reduce before you square or before you cube.
Oh, that's why you can do.
And that's why you have no figures.
Yeah.
You like to create problems.
Yeah.
Complicated your head.
Sorry.
Yes, sir. Need to step up? No.
It's not sharp.
Yeah, that's the one that's also not. Just copy and paste.
Area.
Sway my
What's the area?
Good to see you guys yesterday. Sorry. I came to see you. Your dad said, you need to see your student upset. I'm like, I'm gonna go check them. And he was like, okay, they're gonna be happy to see you. And I said, okay, I need to show them I care more than math, so they know I care about their drama. Then I went to the auditorium, and you were hiding from me. Do you know how many calories I burned climbing these stairs, coming to see you? Yes, ma'am.
Yeah, there's really.
Just explain that. It's not when the length is double. When the length is double means when LA divided by LB is 2. So this is LA divided by LB. This I may not consider anyway because people will write different things. So when the length is double, put this as this fraction is now 2. And then this ratio of the area becomes 2 squared, which is 4. So that's why it's 4.
But you don't have to. Okay. So what I mean, sorry, 1 minute. Is it number 5?
Yeah.
Okay. Okay, I better explain that to everybody. So question 5. Question 5 is asking, what is that question again?
Explain why the area of rectangle.
Explain why the area.
A rectangle increases by factor 4 when the side length is double.
So when the side length is double, we have to explain why the area increased by a factor of 4. What does that mean? Yes, you want to try?
It's like,
Yeah, just try. No, you don't have to. We have all the formula on the board. Come on. No. Just use this. You can explain with this. So if I want to answer such a question, I could say, oh, from this formula, LA divided by LB is that length. Okay, because it says something about the side length is what? When the side length is double. When the side length is double means the ratio of the old and the new is 2. Look at this, the side length is double. From here to here, it's double, right? So it means the ratio of this to this. If I do LB divided by LA, I get 2. Do you understand? 6 divided by this will be 2. So this bracket is going to be 6 divided by 3, all squared, which is 2 squared, and that is 4. And that is the ratio of the area. So area of B divided by area of A is now ratio 4. Do you understand that? So this is enough to explain. From this is what you have. You don't, of course, say this because it says double. Means whatever fraction it is going to result to 2 eventually. So from here, 2 squared is equal to the area of the A and B, or ratio of the area, something like that. Just explain with this formula. This formula is sufficient for your explanation. Okay? And I'm not going to judge anybody for not being able to explain anyway. But I just needed to get the idea. No, you don't have to. Just write what comes to your mind. I'm not going to grade anybody for that number 5.
Oh, okay.
Okay? But I want you to put something down based on your understanding of that formula. It's just the formula that we have written already anyway.
Oh yeah.
Okay? So from that, we're going to get LA divided by LB is now 2. When the side length is double means the enlargement is double, right? So it means the ratio of maybe the second one to the first one is now 2, something like that. Okay? Joey, confused?
Not okay.
Are you confused?
Yeah.
Okay. Maybe I write it properly for you. You can just copy what I'm going to write. You don't have to.
The area of shape B.
From here,
Yes.
what the question is talking about is the ratio of the shapes is now 2 to 1. Okay? So you have to explain why the ratio of the area is 4 to 1. That's what they wanted to explain. So from here, why didn't you substitute? So this ratio is 2 to 1. So 2 over 1 squared is equal to unknown, right? So this unknown ratio is automatically 4. Okay? So read that question. What did they say? Explain why what?
The area of a rectangle increases by a factor of 4 when the side length is double.
So what can you see the increase now? So area of A is actually 4 times the area of B.
Yeah.
So the area of the bigger one is 4 times the area of the smaller one. So the smaller one increased by 4. But look at the ratio of the length. Ratio of the length of A to length of B is 2 to 1. What does that mean? It means length of B is twice length of A.
Yes.
So length of B is double length of A. It's like this. When this increased by 2 to form this shape, what happened to the area? The area increased by ratio of 4.
Yeah.
So your explanation is just this formula.
Okay.
Okay, this happens because in fact, this is enough.
So if I answer
So the answer could have just been, oh, the reason is because length of A ratio length of B squared, the ratio of the length is squared to get the ratio of the areas. That's enough explanation. Okay?
Yeah.
Because you always square it. In the case of if the length was increased by, maybe the ratio of the length is now times 3, then you'll be able to explain with this formula why the ratio of the area will become what? Times 9. Because you have to square it. Okay? Understood? This formula is enough to explain. The only reason is because the ratio of the length will be squared to get the ratio of the area. And remember, double will be squared to get 4. That's it. Yes, please. Okay, just write in your own words. I will not consider that as a mark. It could be a bonus thing. So you don't need to be scared of what to write. Denise?
Yeah.
Yanko? That's the one you gave me last. Okay, you can look at this one. I'm gonna keep it to check for others.
Oh.
Yeah, you missed something.
What is that?
Is this what you missed?
Oh, H.
Jesus Christ. Hey, thanks about Oh, Chad.
Oh, I didn't want to stand.
Good strategy. Good strategy.
Yeah. Why am I repeating the same number? What is going on? This dude wrote 12. I crossed it wrong, and I wrote, he wrote 14. I crossed it is wrong, and I wrote 14. Instead of crossing it to write 12 for him. What is going on? I need to probably see my doctor, right? I'm trying to find out what virus is making me do this. Writing square instead of cube.
What's 20
20 times? 25, that's easy. 500 maybe? Yeah, 500.
9, it's not 9. 3 times 3 times
Let's
3
do
is
2 times
27.
25 and add the one more
This.
zero.
No, you were like, what?
What? What is wrong with this?
Said I'm mad.
What's wrong with this guy?
But what did you do?
This is prime number. Yeah.
What did I pass it?
This is prime number. I think it's a prime number, right? That's not even a prime, so you're not special anymore. Is what?
We thought
You think it's not a prime number? Boom! What? Prime number for the next 2 months. Second prime number of the next 2 months.
Such a lie.
Second prime number of the next 2 months. Well, I don't know. Do you count them based on your belief?
That is so weird.
Come on, guys, seriously. I gave you a small puzzle to know my age, sir, to know my birthday.
It's horrible.
It's not horrible.
My dad just comes to doing this. It's like,
So lucky you, your dad is doing it to you at home, I'm doing it to you in
I feel
school.
bad for Chelsea.
Why do you feel bad for her? Because everything is going to be math in the house. No, it's not.
No, I think
But seriously, truly, my birthday is the second prime number of the next 2 months.
really watch.
Just figure that out, you know my next birthday.
I know. I think I wrote it down somewhere.
June what? June 3rd, come on. Second prime number is 3.
Yes, Bailey man.
In fact, the next 2 months,
Wait, June
2
3rd?
is also a prime number. I'm trying to communicate in a prime way.
Special.
Yeah, those prime numbers are special.
That's my friend's birthday too. Wait, what?
That's what?
That's my friend's birthday.
Well, not my friend, your friend. Kidding. Trudy, look at that. Second prime number of the next 2 months. The second prime number is 3. The next 2 months is June. And what did they say about June? It's the 6th month of the year. And what did they say about 6? It's a perfect number.
The second.
Hold on, I'm not done yet. What is the perfect number?
I can't believe it.
6.
What are the factors of 6? 1, 2, 3, 6. You have these guys, they get this back.
Yes.